In this video, we are going to learn how to solve one-step equations with multiplication and division. Let's go ahead and begin. So we're going to start off with like this warm-up, this exercise. On top, let's see, what's 5 times 8? 5 times 8 is 40, right? Now what's 3 times 7 divided by 3? Well, 3 times 7 is 21, and if I divide that by 3, I just get 7. What's 10 times 4 divided by 10? Well, 10 times 4 is 40. Divide that by 10 is just 4 again. Do you notice a pattern here? If I multiply 7 by 3 and divide by 3, I'm left with 7. If I multiply 4 by 10 and divide by 10, I am left with 4. Take a look at this. I'm multiplying 97 times 21 divided by 21. If I multiply 97 by 21 and divide by 21 at the same time, guess what I'm going to get? I'm just going to get 97. And what's going on here is if you multiply a number, multiply then divide by that number, it basically is almost like it cancels that number out. So 4 times 10 divided by 10 is 4. 7 times 3 divided by 3 is 7. 97 times 21 divided by 21, guess what? That's just 97. Let's take a look at the bottom. 70 divided by 10, that's 7. What's 8 divided by 2 times 2? Well, 8 divided by 2 is 4. But if I multiply that by 2, I get 8 again. Let's see, if I divide 30 divided by 5, I get 6. And if I multiply that by 5, I get 30 again. What's the pattern here? Well, if I divide a number by 2 and then multiply by 2, I get my original number again. Divide by 5, then multiply by 5 again, I get my original number. 7 divided by 8 times 8. What does that equal? Equals 7. So it's almost like if you are dividing and multiplying by the same number, it almost cancels each other out. So what's the point of all this? Multiplication and division cancel each other out. Like 8 divided by 5 times 5 is just 8. If I did 30 divided by 1,000,000 times 1,000,000, I end up with 30 again. So because multiplication and division are inverse operations, they are the opposites of each other. They cancel each other out. And when they cancel each other out, you're left with 1. So we need to solve the algebraic equation, check our answers, then we graph it on the number line. Let's take a look at example 1. 2 times x equals 10. To do this, 2 is being multiplied by x. What is the opposite of multiplying by x? Well, you divide. Because whatever you do on one side of the equation, or you could do anything to this side of the equation. So 2 divided by 2, that basically cancels it out, and I'm left with x. Kind of like this over here. If I multiply by 3 and divide by 3, I'm cross it out, and I'm left with 7, basically. So 2 divided by 2 cancels out. It equals 1, and I'm left with 1x. If I divide this side by 2, I need to divide the other side by 2 as well. So 10 divided by 2. What's that equal? Well, the 2's canceled out over here, which leaves me with x. 10 divided by 2 is 5. And that's my answer. So let's check my answer. Let's make sure it's right. Does 2 times 5 equal 10? Yep, yes it does. All good. How do I graph this? Well, let's go ahead and do, well, 5 is over here. Let's do 0, 5. Looks like that. You can also do like 4, 5, and 6. You don't have to, draw the 1, 2, 3, 4, 5, 6. Just, you can do the numbers around it, or you can do like have that compared with 0. All right, let's try number 2. We have 5 times y equals 30. 5 times what number equals 30? You may know that the answer is 6, but let's do it the other way. Let's cancel out the 5. Let's do it algebraically by cancel out the 5 by dividing by 5. So 5 times y, opposite of multiplying by 5 is dividing by 5. So if I divide by 5 there, I divide by 5 here, I'm left with y, and that equals 6. Does y equal 6? Let's check out our answer. 5 times 6 equals 30. Is that true? It is. This checks out. So to graph that, we have 0, and I guess the number is 6 right there. It's just a dot on 6. Let's try number 3. 12 equals 4x. 12 equals 4 times what number? You may know the answer, but let's just do it algebraically by canceling out. 4 times x divided, opposite of multiplying by x is dividing. Sorry, the opposite of multiplying by 4 is dividing by 4. So I'm going to divide both sides by 4. This cancels. I'm left with x, and 12 divided by 4 is 3. Let's see, is x 3? Does 12 equals 4 times 3? Yes, it does, because that's 12. That checks out. Let's graph it. 0 and 3 would be like right there. Let's take a look at number 4. I'm going to draw a line down the middle to indicate that I have two sides of an equation. 36 equals 12 times y. So opposite of multiplying by 12 is dividing by 12. That lets me cancel that out and leaves me with y. 36 divided by 12 is 3. Let's check to see if our answer is correct. Y is 3. So does 3 times 12 equal 36? It does. Answer checks out. Let's graph that. 0, and that's 3. 3 is like right there on the number line. All right, example 5. Y divided by 4 equals 3. What number divided by 4 equals 3? You may know the answer, but we're going to solve this algebraically because sometimes the numbers get more complicated. So what is the opposite of dividing y by 4? Well, multiplying by 4. And I'm actually going to write that like this. Now, you may decide, technically what you're supposed to do is actually go like this. And that's actually the more proper way to do it. But you know what? To keep things simple, I am just going to do the dot, multiplication dot. 4 times y over 4. And if I do multiply this side by 4, I multiply the other side by 4, this cancels it out. Just like it does up here, right? Because if I divide by a number and then multiply by that same number, it cancels it out and leaves me with the original number. So y is being divided by 4. If I multiply that by 4, it cancels that out. Leaves me with the original. So that leaves me with y. And 3 times 4 is 12. Let's see if that's correct. Does 12 divided by 4 equal 3? It does. That's checks out. How do I graph 12? Well, 0 goes right here. 12 is somewhere up there. Graph that. All right, let's take a look at 6. X divided by 2 equals 8. What divided by 2? Well, let's just do our algebra. So I'm going to multiply this side by 4. If x is being divided by 2, I have to do the opposite of dividing by 2, which is multiplying by 2. That will end up canceling out. You're left with x. 8 times 2 is 16. Let's see if that is actually true. Does 16 divided by 2 equal 8? It does. That checks out. Let's graph that. 0, 16 is like up there, I guess. It's right there. There you go. Let's try example 7. 10 equals x divided by 5. All right. The opposite of dividing by 5 is multiplying by 5, so I'm going to multiply by 5. That cancels. This equals 50. Does 50 divided by 5 equal 10? It does. 10 equals 10. That is true. Let's graph 50. And last one, x divided by 7 equals 0. How do I solve this? The opposite of dividing by 7 is multiplying by 7. Multiply both sides by 7. That cancels. 7 times 0 is still 0, so x equals 0. Let's see if that's true. Does 0 equal 0 divided by 7? What is 0 divided by 7? It's 0. That is true, so let's graph that. 0 is just right there. If you want to put numbers around it, 1 and -1, you don't necessarily have to. All right, let's take a look at the second page. How do we solve an equation that involves multiplying or dividing by a fraction? Well, when a variable is multiplied by a fraction, you divide it by itself to get it to cancel out, which is the same thing as multiplying the fraction by its reciprocal. Then do the same thing to the other side of the equal sign. What do we mean by that? Well, imagine we have 1/6. What's 1/6 divided by 1/6? It's 1, right? 1. If you now, how do I actually do division with fractions? Well, if you remember, when you divide, oops, 1/6 divided by 1/6, dividing by a fraction requires you to do something called, requires us to keep, change, flip. So let's do number 9. Well, actually, let me do it over here. Don't write this down, but we have 1/6 times x equals 12. Now, rather than writing division like, oh, divide this by 1/6, which cancels out, and then you're dividing 12 by 1/6, which is kind of weird. Remember what that's dividing by a fraction involves this process. So 1/6 divided by 1/6. You don't, the way we divide is we keep, change, flip. So we keep the 1/6, we change the division to multiplication, and we flip the 1 over 6 to 6 over 1. You're multiplied by the reciprocal, and a reciprocal is just a flipped fraction. And when we multiply, what's 1 times 6? That's 6. What's 6 times 1? That's also 6. And what's 6 divided by 6? It's 1, which leaves us with, 1x. Basically, that's what we mean by canceling out, because it turns into a 1, and 1 times x is just x. 1 times any number is itself. So rather than writing divided by 1/6, dividing by 1/6, I just kind of skip that step. And I jump straight to like, oh, just multiply by 6 over 1, multiply by the reciprocal. So 1/6 times 6 over 1, rather than saying, oh, that's just 6 over 6x. I don't do that because 6 over 6 is 1. So I just cancel that out. I'm left with x. 12 times 6 over 1, well, that's, 12 over 1 times 6 over 1. Multiply the top, that's 36. No, sorry, that's 72. And then 72 over 1 is just 72. So my answer is 72. Well, let's make sure that's true. So 1/6 times 72, does that equal 12? Well, let's see. 72 times 1, that's 72 over 6, which equals 12. Does 72 divided by 6 equal 12? It does, so that is true. Let's try number 10. X divided by 6 equals 12. We'll multiply by 6, right? Multiply by that by 6. This cancels. We're left with x equals 72. And again, does 72 divided by 6 equal 12? It does. What do you notice about 9 and 10? We notice that basically 1/6 x is the same thing as x over 6. Now, if you think about it, I'm going to kind of do it on the side. If you think about that, like if x was a number, if x was like the number, no, 12, for example, 1/6 times 12 would be the same thing as 12 over 6. Because what is 1/6 times 12? Well, it's 1/6 times 12 over 1, which is like, oh, that's basically just 12 over 6, right? So something that could be helpful for you to know is 1/6x is the same thing as x over 6. Because when you multiply 1/6 times x, you end up with x over 6. So that's kind of a nifty little fact for you to keep in your pocket. Let's go ahead and try some harder ones. 3/4 y equals 12. So again, rather than doing, oh, you divide by 3/4 and then I divide this by 3/4, because that's the same thing as multiplying by the reciprocal, I skip that step. And I say, all right, just multiply by the reciprocal, 4/3. Multiply this by 4/3. That cancels. I'm left with y. That's 12 over 1 times 4 over 3. That's 48 over 3. 48 divided by 3 is, I believe, that is 15. 16. That is 16. Yeah, that is 16. So, is the answer 16? Well, let's see. 3/4 times 16 equal 12. Is that true? That's 60. That's 75. That's 78 divided by 4. 78 divided by 4 equals 12, not 78. Not 78. It's 48 over 4. I mean, it's 48 over 4. Does 48 divided by 4 equal 12? It does. That checks out. Let's try number 12. Again, I'm not 2/3 times x. I could just divide by 2/3, but dividing by 2/3 is the same thing as multiplying by 3 over 2. So I'm just going to skip that step and multiply by 3 over 2. That cancels out. 6 times 3 over 2. I'm going to give you kind of a trick. Rather than doing this, I can also do this. Multiply 6 by 3, and then you divide by 2. Multiply by the top, divide by 2. I can actually divide by 2 first and then multiply by 3, whichever one works better for me. Because if I do 6 times 3, that's 18. Divide that by 2, I get 9. If I do 6 divided by 2 first, that's 6 divided by 2 is 3. 3, and then you multiply by 3 afterward, you get 9. So you still end up with 9 either way. So x equals 9. So let's see if that is true. Does 2/3 times 9 equal 6? Well, 9 divided by 3 is 3, times 2 is 6. Yes, the answer checks out. Let's try number 13. Again, I could say, oh, divide by 1/3. But dividing by 1/3 is the same thing, whoops, as multiplying by the reciprocal. So I'm not going to write divide by 1/3. I'm going to multiply by 3 over 1. Multiply by the reciprocal. So that cancels that out. I'm left with x. 9 times 3 over 1, so 9 times 3, that's 27. Divided by 1 is 27. Let's see. Does 9 equal 1/3 times 27? What's 27 times 1/3? Well, it's 27 times 1 divided by 3, which is, that is 9. So yes, this checks out. Finally, 2/5, 2x divided by 5 equals 4. This is the same thing as 2/5 x. So, which means you can basically multiply by 5, divide by 2. Another way to think about this is we have x being divided by 5, being multiplied by 2, and divided by 5. So I have to do the opposite of multiplying by 5. Sorry, do the opposite of multiplying by 2 and the opposite of dividing by 5. So let's do it step by step. Let's do the opposite of dividing by 5 first. The opposite of dividing by 5 is multiplying by 5, right? If I do that, I get the 5's cancel out. I'm left with 20. So I'm left with 2x equals 20. Now I have to do the opposite of multiplying by 2, which is dividing by 2. I'm left with x. 10 equals x, or x equals 10. Let's check to make sure that is correct. Does 4 equal 2 times 10 divided by 5? Well, 2 times 10 is 20. And 20 divided by 5 is 4. So yes, it does check out. Let's say I thought of it the other way, like I said, which is like, just look at this as if it is 4 equals 2/5 x, which is the same thing. You multiply by the reciprocal, 5 over 2. Multiply the other side by 5 over 2 as well. That cancels. You're left with x. 4 times 5 is 20. Divide that by 2. You end up with 10. So you end up with the right answer either way. But that is how we deal with equations, solving equations that involve both multiplication and division. Go ahead and try some problems on your own.